Okay, let's try this again, shall we? So, while I was resetting things, I looked at the comments, and there were people saying, oh, things are good now, and people saying things are bad now at exactly the same time. So, I don't know that the problem was necessarily just at my end. However, I have switched microphones, and hopefully we can... Yeah, the music came through good, and hopefully the audio will now work. I'm going to try this switch here, and things look like they are working here. Is the audio working out there? I hope it is. Hopefully folks have made it back or are starting to come back, so let us know that the audio is working. I really hope so. Sorry about that. Oh, good. Okay. Thanks, James, for checking things out. I appreciate that. All right. We are going to try this whole thing again because that was a little bit crazy. Okay. Let us, first of all, great. I'm glad everybody's checking in. Okay. Dome at Home, Treaty 1 Territory, Winnipeg, Manitoba Museum. I said all that last time. I'll dub it in later so that the final video looks okay. Okay, we're going to talk about an upcoming event that I'd like to tell you about. We're going to look at some of your images, and then we're going to get into some of the things that are going on right now. We've got the planetary parade, we've got the upcoming lunar eclipse, and we've got all sorts of cool space stuff. So thanks for joining us, everyone. Very cool to have you here. We've been going up and down here in Winnipeg. Today the temperature was around -5. Everything was starting to melt a little bit. Perfect. My youngest kiddo is doing driver's ed and just got their learner's permit. So they've basically learned to drive on solid ice in blowing snow and in melting ice, basically all within 48 hours. So Winnipeg weather, but hasn't been doing us too many favors for clear skies. Although I have seen some folks get out and get some great shots of the planetary parade. We'll talk a little bit about that in a second. I wanted to give you that save the date. Yuri's Night, April the 10th, Friday, April the 10th. It'll be at the Planetarium and Science Gallery. Tickets should go on sale in about a week or so. And for those of you that have never been to a Yuri's Night, we used to do this back 10 years ago or so, in the pre-COVID time for sure. And it's basically a space party. You go to the Planetarium and Science Gallery, there's music playing, DJs, there's dancing under the stars, there's a space-themed costume contest, there's science activities, and different science groups are there demonstrating all the cool stuff that they have, kind of like live cool space stuff. Really cool. And just a great time. So that's coming up Friday, April the 10th. Tickets will go on sale probably in about a week or so. We have DJ Manalog and DJ Lowtech, who together are The Shake, headlining again this year. They're sort of my partners in crime, putting Yuri's Night together for the last, I think we did the first one in 2011. And it was a great time. So that's coming up. Good thing to save the date. You definitely want to come and hang out. And of course, it's basically just like take Dome at Home and add pizza and drinks and dancing. It's basically that. So keep that clear, and hopefully we'll see you then. I know there's other things going on that night, but Yuri's Night is based on the day of the space flights, and we have to basically go along with that. So, all right, let's get to some of your images. Krish, my friend Krish down in Houston, thanks for joining us. I saw you check in before. I hope you made it back. Krish is one of the guys that is using these smart telescopes and doing some amazing work. And last month, we talked about Orion, and we were doing the constellation Orion as well as the spacecraft Orion. And we had lots of pictures of the Great Orion Nebula, but then there's another object in Orion called M78, Messier 78. And I said, well, I haven't seen many people take pictures of it because it's upstaged by its brighter cousin that's just a little bit away. And so I challenged Krish to shoot it, and so he did. So there's beautiful shot of like there's a little star cluster, and then all of these nebulosity, this cloud of gas, and these dark areas. This is a great shot of the complex of M78. This would be one of those things that would really stand out in the sky if it wasn't right next door to so many other amazing things. The Great Orion Nebula, and the Horsehead Nebula is a great target for imaging, and the Rosette Nebula nearby, and things like that. So thanks a lot, Krish, for shooting that. And I'm gonna work on a few more challenges to send your way to see what you can get out of that little Dwarf 3 smart scope. It's pretty darn impressive. Here's a picture that I took. I don't know exactly when, maybe over the last month or so, but this is called the Owl Cluster. And actually, I think we talked about it in one of Ulrika's binocular challenges on Cassiopeia, because this is a little star cluster in Cassiopeia. And if you think about these two stars being eyes, and then the body of the owl is sort of here, and then there's sort of two chains of stars that go out on either side that kind of make the wings. It doesn't show up as much in a photograph, but when you're looking at it in the eyepiece, it actually looks like an owl sitting there with its wings spread. That's what most people see it. I see it as some kind of zombie or something like that, because the first time I saw it, I was, I don't know, 12 or so, and I was out in the dark by myself, and I saw this creature with its arms spread wide coming towards me. Anyway, a nice little cluster. The lines going across here are from one of the satellites that just went through the field of view. But I just tossed this in as a little nod to, this is actually something you can see in binoculars, and it looks really, really cool in a small telescope. So definitely worth checking out. Ulrika was able to catch the Moon and Jupiter right next to each other. And I didn't get a chance to see this. I think we had some kind of cloud in this area, if I recall, when they passed each other. But back at just after the last show at the end of January. So it's one of those reminders that, every month the moon goes around the sky, it passes different things, and it can make a nice photo op for some of these things. So thanks for getting out and shooting that, and thanks for sharing the image there, Ulrika. We'll have more content from Ulrika's binocular challenge. We actually were hoping to have one tonight, but with my computer failure, it just wasn't going to happen. So we'll get that to you sometime soon, because there's lots of good stuff that Ulrika's been doing with the binoculars. Here's another Krish picture, and this is the kind of thing that outshines M78. This is the Rosette Nebula that is nearby, not in Orion, but it's a little bit farther to the left, farther to the east, in the constellation of Monoceros or Monoceros, the unicorn. And if you expect to see a unicorn in the sky, you'll be disappointed, because it's like three faint stars. It does not look like a unicorn. But one of the best images, one of the best things to image in the sky is this Rosette Nebula. There's a star cluster down in the middle, and then surrounding it, the glorious red imaging of the hydrogen gas that is the formation of stars. And then you can even see in this image, which is usually you don't see in smaller images, you need like a bigger telescope, all of these little dark dust lanes. Oops. Let's come back here. All of these little dark dust lanes that are, where the material is actually clumping together and getting thicker. That's the kind of stuff that eventually collapses down and makes stars or planets or things like that. So, pretty interesting shot. And look at the details there. Krish was shooting for 4 hours with the telescope, taking exposures every probably 30 seconds or so, and then adding them up. So that's a lot of work to put that together. Beautiful image, and I am definitely very impressed with the views here. So that is the view that we've got here. Oh, we've got another couple of images, I think. Let's see what we've got here. Oh, Gia Walker, one of our regular contributors, great photographer, does all sorts of really amazing sky stuff, gave us this warp speed view of Orion. And, you take a picture of the sky and the camera has to expose for a few seconds to soak in the light of the stars because the stars are pretty faint. And so while it was exposing, she just zoomed in the lens. And so it started with the wide view and then zoomed in, and you get this sort of warp effect of all the stars going around it. It has a couple of effects. First of all, it just looks really cool. Second of all, you can see the difference between stars, which make a nice sort of even line, and then the Orion Nebula, which is a wider kind of line. And you can really see the colors show up. These yellowy and reddish colors. This is Betelgeuse here, sort of orangey red. And then here we have the Rigel is bright white as well. So there's all sorts of cool stuff in this image. And I think I did just a close up as well, just to really show there's one star there that looks like it was right in the center of the field of view, and then everything zooms around that. Very cool. A nice artistic shot and really good stuff. Thanks a lot, Gia, for sharing that with us. You can send us your images. We would love to show what you're doing, whether you're drawing pictures of things or whether you're taking images of the solar system or nebulas or stars or anything astronomical. We would definitely love to see. And you can send them to me at space@manitobamuseum.ca. Or you can get a hold of the museum through any of the places, wherever you're watching the podcast, they'd be able to hook you up with that. All right, I saw a question go by. Someone was asking, when does the section on the lunar eclipse start? Well, it's part of our section that starts right now, where we look at what's up in the sky. It is one of those times where we're getting all of the planetary parade emails around. I don't know if you've seen them on social media. There's these pictures of 6 planets all lined up, and of course none of that is actually realistic. However, and in fact, for worse, they're saying it doesn't happen till February 28th. So on February the 28th, you actually will have missed some of the best action of the planets right now, because tonight, well, here it's cloudy, but if you happen to be clear wherever you are, go outside at, as soon after sunset as you can. It might already be a little late if you're here, if you're in eastern half of the province, but if you're, west of Manitoba, you can go outside about 6:30 local time, and you'll see, first of all, bright Venus. And then to its upper right, much fainter but still visible, will be Mercury, and then Saturn up there. And each night, those things basically shift their position as they orbit around the sun. Now there's also the planet Neptune, which is over near Saturn, but totally invisible. Even in binoculars, you won't see it because the sky is just too bright. It's too close to the sun. And then Uranus is sort of over here somewhere, also invisible. And then Jupiter, which we've been watching for the last year or so, is way on the other side of the sky. So technically, they're all lined up, but they're always all lined up. That's the way the solar system works. So don't wait till the 28th to go out. Go out as soon as you can. And, so here's the view tomorrow night. Mercury actually gets a little closer to Venus. Saturn moves in a little bit. Venus is kind of moving mostly to the right, and Mercury is starting to sink down low, and Saturn is also starting to sink down low. And so, by the next night, we get to a situation like this where Mercury's quite a bit lower and quite a bit fainter. You'll probably lose sight of it after about the 28th. Saturn's bright enough and high enough, we'll see it for a while, but over the course of the month, Venus will kind of move up that way and Saturn will move down this way, and the two will come together. And I'm sure we'll see another spate of social media excitement about another planetary alignment. They're always lining up. I mean, that's what planets do. They all go around the sun at different speeds and they pass each other. We see that with the moon passing things and so on. So I don't know. Basically any clear night is a great night to go and look at the planets. That's what I figure. Okay. I did those first because those are happening right now, but coming up in the first couple of days of March, we have a total lunar eclipse. Now, there's a bunch of misinformation about this online as well, because I had somebody asking me, they heard that, it was the first total lunar eclipse in the last 50 years visible here. No, we saw one literally last March. Lunar eclipses are not terribly rare. There's a couple every year, sometimes 3, and the whole half of the planet can see them. They're not like solar eclipses where you have to be in just exactly the right spot to to see the best view, everybody gets the best view of a lunar eclipse. And so late on the night of Monday, March 2nd, really early in the morning of March the 3rd, is when this eclipse happens. I've been saying it that way because a lot of places say, oh, on March 3rd, go out and see the lunar eclipse. And so people will go out the night of March 3rd and they will have missed it by 24 hours. So what we will see is a total lunar eclipse, or the media calls it a blood moon because the moon turns red. Here's a fast version, and then we'll slow it down and take a look. But basically, the eclipse progresses through a number of different phases. We start with the penumbral phase, which is very, very subtle. Then we have a partial phase, then the red blood moon phase. Then it sort of unwinds and redoes it. Here, let's do this again. Here's the penumbral phase. You might notice on the left, there's a bit of a shadow creeping in, but it's not very dramatic. A lot of people don't even notice it. And then the main eclipse starts around 10 to 4 in the morning Central Time. That lasts till just after 5 when the moon finally goes into the full shadow of the Earth. And here, let's pause this here. And you wind up getting the beautiful red color. Now, the red color is always there. If we rewind this, the red color is here too. It's just that the bright part of the moon is so much brighter than the shadow that it basically just saturates our eyes, and this red is lost in the glare. So sometimes in an image you can see that there's red here, but because of this bright part of the moon, it's just so much brighter that our eyes just can't adapt and see that color. So for most people, the color doesn't become visible until just before totality, when that bright part of the moon is just a thin little sliver. So around 5 in the morning. And then the moon basically is in the central shadow of the Earth for almost an hour. So the peak, or the moment of greatest eclipse, is around 5:34. That's the time that the moon is basically the deepest into Earth's shadow. But that is not the moment that you necessarily want to go out and see the eclipse. If you're not going to go and watch the whole thing, if you want like the 15-minute period of when to see it, I would suggest going for this part. Go out at like 4:45. You'll see a thin little sliver of moon, and over the next 15 minutes, you'll be able to watch as that sliver of moon gets smaller and smaller and smaller. And then once all the white part disappears, you'll have the colors of the eclipse, whatever they happen to be that particular eclipse. Because here's the thing, that color is not a sort of a set standard color. Sometimes it's very deep red or orange. Sometimes it's sort of a coppery brown. Sometimes it's kind of orange yellow. I've seen one eclipse where the shadow of the Earth was so dark that it just looked black. Actually, you couldn't even see the moon unless you knew where to look for it. Well, what's going on here? All of the things that we're seeing during a lunar eclipse have to do with the Earth and the sun and the moon. So you've got the sun on one side, you've got the Earth in the middle, and so the sun is shining onto the Earth. We get a daytime side and a nighttime side. And then the Earth's shadow extends out into space. And the moon is moving into that shadow. The moon does not glow on its own. It only is visible. It's just a rock. It only is visible because there's sunlight shining on it. So the rest of the time, when we're looking at the moon, we're looking at a rock that is got sunlight shining on it. Well, if it starts to move into the shadow of the Earth, less sunlight shines on it. And we start to see the penumbral phase of the eclipse, where it's starting to get a little bit darker, but it's not very well defined. The outer part of the shadow is kind of fuzzy, and so it sort of fades in as the moon sort of moves into that part. But then, when the moon gets into what's called the umbra, the deeper part of the Earth's shadow, that's when you can really see the defined edge. And even then, it's still a little bit fuzzy. And during that partial phase, the moon is moving into the deep part of the shadow of the Earth. And in totality, the moon is completely inside the shadow of the Earth. So there should be no direct sunlight hitting the moon at all. So the moon should actually become invisible. And it would if the planet Earth was just another rock like the moon. If we were just a planet made of rock, we would block out the sun completely and that would be it. But we've got stuff going on the Earth. There's a very thin layer around the Earth called the atmosphere, the air. And that allows the sunlight to sort of do some interesting things. The sunlight doesn't have to travel just in a straight line. And if you've seen anything from a rainbow to sundogs to the beautiful colors of a sunset or a sunrise, you know the kinds of things that the atmosphere does to the light from the sun. During a lunar eclipse, the only light that can reach the moon is the collected light from all of the sunrises and all of the sunsets all around the world. And so that red light that we're used to seeing during a beautiful sunrise, that's the only light that can get through the atmosphere, and still sort of, it actually curves a little bit because of our atmosphere, almost like a lens would focus the light, and it can still hit the moon in the shadow. All the other colors, the green and blue and violet and stuff like that, that gets sort of scattered out or absorbed in the atmosphere, or it doesn't bend enough to get into the shadow. And so you wind up with only this red-orange color. So the weather at the edge of the Earth all the way around affects how much of that light gets through. If you've got, perfectly clear skies all the way around the Earth, all the sunlight can sort of go through the atmosphere, and all of those sunrises and sunsets are nice and clear, and that red light lights up the moon. You get a beautiful bright red moon. If there's clouds in some spots, that'll dim the light a little bit. If there's a lot of clouds, you can actually have quite a dark eclipse. The one that I saw where it was black was just after Mount Pinatubo in the Philippines. The volcano erupted, and it put a whole bunch of ash up into the atmosphere, and that was enough to block more light and really make the eclipse quite dim. So it's kind of cool that, you by watching a lunar eclipse, it actually gives us a little bit of a measurement of the clarity of the atmosphere on that part of the Earth all the way around the edge where the sunlight is coming around. It's also really cool to watch and beautiful. We streamed our lunar eclipse last year, March 15th, I think it was, 14th and 15th. And that was a beautiful view, the second half of it. James, you were there, and Tracy, I think you were there, and who else was there? I can't remember. Anyway, we had the stream team out there, and it was a really, really nice night for the second half. The first half, kind of cloudy. We had some technical issues, surprise, and we were outside in the cold and so on. We're going to try it again this time. So if you do want to see the eclipse, first of all, just stick your head outside. If it's clear, you don't need a telescope or anything like that. It's actually really impressive just with the eye. If you have binoculars, those are great. They give you a little bit more magnification without sort of zooming in too much. You can really get a nice view of the colors that way as well, but you don't even need those. If you've got a telescope, that's great too, but use your low power wide field eyepieces. You don't want to zoom in on this. You want to see the whole moon and be able to see the beautiful shading of colors as it goes across there. Okay, we'll just let this animation run again from about here. So yeah, if you're only going to watch 15 minutes worth, go just before 5 o'clock. You'll see the last bit of partial and then the colors of totality, and then go for a nap and come back. I'm probably going to be on and off throughout the course of that. Now, for us in Manitoba, before the eclipse ends, the moon sets right at 7 o'clock, and so that's a little inconvenience, but it's one of those things that, well, what can you do? You got to take what nature gives you, and so it's kind of neat. Watch what the moon does. Here, we'll move forward a little bit here. As the moon is setting, you notice it sort of becomes not round. It sort of gets squished there. That's another distortion effect of our atmosphere. As things set, they actually get distorted that way. And you can see that in sunsets. You definitely see it when the moon goes down, and it sort of becomes this sort of football shape almost. So that's something to watch for. Folks farther west, if you're in, often Alberta or BC or the Western US, you'll get to see more of the eclipse before the moon sets. Unfortunately, for folks farther east, if you're in Ontario or if you're in Atlantic Canada or the eastern seaboard of the US, you're probably not going to see much of anything. You'll only get a little bit of the partial phase before the moon sets for you. So it's one of those things that everybody across the continent can see some of it. Us here in the center get to see all the way through totality, but probably the best view, I would say, like in Canada, would be maybe, Saskatchewan, Alberta into BC, because you'd sort of get to see the whole thing. However, the whole thing is 6 hours long. And I have to say, when I've been up at 2 a.m. watching a lunar eclipse, and we watch the, hour-long penumbral phase, and then the hour-long partial phase, and then the hour-long totality, and then basically you're watching the same thing happen again in reverse, it's pretty easy to sort of say, been there, done that, and not watch the whole eclipse. So the first half of the eclipse, I think, is the more striking. Now, we do have, I've got an article on the Manitoba Museum's website and our blog page that has all the details of the times for all the different time zones and things like that. So the exact moment when each phase starts. Although, because an eclipse like this, a lunar eclipse, is so slow and sedate, it's the exact time doesn't matter. I mean, you might think, oh well, let's watch for the first moment the shadow goes onto the moon, and that will be something that is a moment that is definable. Well, not really, because the shadow's fuzzy, and it's actually we can't predict exactly how big the Earth's shadow will be at the distance of the moon, because the atmosphere of the Earth actually expands and contracts a little bit. You get everything from high pressure, low pressure weather kinds of things, to the sun sending energy and making the upper parts of the atmosphere expand a little bit because there's more activity going on there. There's all sorts of these things that make it, scientists will still time when the shadow moves across different craters as a reference point to see what the atmosphere is doing. So don't worry too much about the times. If you had a half an hour, I would say, 4:45 to 5:15. That's probably a get up early rather than a stay up late kind of thing, although your mileage may vary. It's going to be, I'm hoping, clear. And unfortunately, it is a Monday night into Tuesday, so it doesn't give us the best kind of view. Let me just see. I know that some questions went by here. Oh, Tara's asking, why in September did I see an eclipse in Italy but not visible in Canada? Great question. So yeah, there was a lunar eclipse in September, and basically it lasts for about 5 or 6 hours, and depending on when it happens, it might happen when the moon's on the other side of the Earth from you, and so you're just looking in the wrong way. Just like in this eclipse, we get to see most of it, but then the moon sets. Well, sometimes the whole thing happens when the moon is not visible to your part. So basically half the world, well, a little bit more than half the world, gets to see every lunar eclipse. And it just is essentially the luck of the draw on exactly when it happens. And so we were lucky to see the one in last March and then this March, but we missed on the one in September, which apparently was a really nice one. I did see some of the online images. Kevin, yeah, I know you're missing out. You've seen a number of lunar eclipses in your day, though, so I think you'll be okay. But yeah, it's definitely something worth getting up for. Like sometimes you'll see something and there's an event and it's 3 a.m. and you're like, is it really worth it? Well, a lunar eclipse really is. It's beautiful, first of all. It's easy to observe, so it's not like you're spending a lot of technical effort or things like that. It's just go out and look at it, take pictures if you want. But it also reminds us that we are part of this whole celestial clockwork. It's not just us in our house, in our city, with all of the things that we think about. We're on a planet, and that planet is in space, and it is orbiting around a star. And orbiting around our planet is a satellite that we call the moon. And every once in a while, they line up in a way that dramatically reminds us that we are part of this solar system. And we're really lucky, actually, because it just so happens that the way things line up, the moon in the sky is about the same size as the sun in the sky. And so that means that we have a lunar eclipse that lasts for 6 hours instead of, say, a week or something like that. So it's rare enough to be special, but not so rare that you never get to see it. And on the converse, when the moon goes around and blocks out the sun, it exactly blocks out the sun. We get the glorious total solar eclipse. That doesn't happen anywhere else. The moon is 400 times bigger, the moon is 400 times smaller than the sun, but it's 400 times closer, and so they look almost exactly the same, and that's what gives us the great total eclipses. There is an eclipse coming up this summer in Spain, and then next summer I'm going to be in Morocco to see the eclipse in August of 2027. So there's a couple of solar eclipses. There are great places to if you like to travel and you have the opportunity to travel. If not, there's almost always a live stream too. And my kids and I have watched every eclipse since 2017, either in person, 2017, or just online, because it's clear somewhere. It can't be cloudy everywhere. Let's see. Kevin, yeah, 1992, that's when it was. Yeah, I was at the University of Manitoba, and we did a public event there, and it was too dark to see the moon. And yeah, it was December, I remember, because it was freezing. We were, Winterpeg, we were at like minus 30, beautifully clear. It would have been a great night to see a nice bright eclipse, but you could see it in the telescope. And if you knew exactly where to look, you could kind of tell where it was. There were enough bright stars nearby that you could kind of see where it should be, but it was just so dark. I've never seen one like that before or since. There's rumors, although I'm not 100% sure that I believe them, that the whole idea of the blue moon that we've heard of might be related to a volcanic eruption that caused the moon to actually appear blue during a lunar eclipse. I don't know. I don't understand how that would happen scientifically. However, I've heard that claim multiple times, and who knows? Maybe there's a way that would work. But anyway, that is our big event coming up. Probably one of the best events for the year. So definitely worth setting your alarm for and getting up. Now, if you're going to get up and spend time out under the sky in the first couple of days of March, if it's clear, it will be cold. And in astronomy is not an aerobic activity. Make sure you are, either close enough to a place you can go and warm up, or in a position to have blankets and warm drinks and whatever you need. The great thing about the geometry of this particular eclipse is that the moon will be quite high in the sky. So you don't have to go somewhere out of town where you have a flat horizon. You can probably, as long as you can find a place where there's no light shining right in your face, even just like hide on the side of a building or something like that to block out a street light, the moon will be so high that for the early part of the eclipse, certainly for us here in Manitoba, we'll have a really, really good view of it. Now, of course, it does get down lower and lower as the night goes on, as it sets, and then towards the end, it actually will set. So if you want to see the whole eclipse, you need that good horizon down to the sort of west and southwest. But the rest of the time, it'll be a very accessible, like I think you'll be able to see it from Portage and Main downtown in Winnipeg, basically, as long as you walk to a spot where there isn't physically a building in your way. So hopefully a lot of people will get a chance to see it. So if you have any questions about the eclipse or about, I was going to mention imaging the eclipse. If you've got a phone, your camera will almost certainly take great pictures of the eclipse. However, I recommend learning how to use the camera on your phone. You can just point and shoot, but often when there's like one bright thing and a bunch of darkness, the auto everything doesn't quite know what to do. So figure out how your camera focuses and how you can change the exposure on your camera. For me, when I press the camera, that won't necessarily. Oh, there's a light there. Okay. You basically just stick your finger. Let's get it in the camera here, and you tap on the object you want to focus on. A little box will show up, and you can adjust a little lever on the side to make the exposure more or less. Just see which one looks better. And often, if you press and hold on that object, it will actually sort of lock it so that the focus doesn't change. Because, you're taking pictures and the autofocus tries to use the sensors in here to focus on things, and it's used to focusing on, me and someone 5 feet away or whatever, or selfies, and it doesn't reach the moon. So it doesn't autofocus very easily on the moon in a lot of cases. Some of the newer cameras are surprisingly good at it, but if you've got an older phone, just spend a couple minutes figuring that out before you're out there at 3 a.m. in minus 20 degree weather, because it's a lot more frustrating to figure it out then. Alrighty. I have another section here that I like to call
Cool Space Stuff!
So I'm not sure cool is the right word, but last show we introduced the Artemis II mission and the crew and the mission to loop around the moon, and we thought that might be the last show before the mission was over. I thought I'd be doing a recap at this point because, the launch was scheduled to be in February. Well, they were doing the test before that launch, so on February 3rd, they did the fueling test, and the launch was scheduled for February 6th. That was a little tight, but we thought, okay. But then they had some drama in the test. They were supposed to count down. It's a 50-hour countdown. They fueled up the rocket with all the super cold hydrogen and oxygen and stuff. They did everything except put the astronauts on board as a test to make sure everything worked. And if it worked, they were going to do it again with astronauts. Well, it didn't quite work. They had a hydrogen leak. Now, hydrogen is what you use in that big orange fuel tank there. It's a very good rocket fuel. The problem is hydrogen, the molecules, the atoms of it are very small. They're the smallest ones there are. And so it's really easy for that stuff to leak out of other materials. Even if you've got, perfect seals, hydrogen can find a way through the smallest spaces. So every rocket that uses hydrogen has hydrogen leaks. That's a given. You can't stop them. It is literally impossible to completely stop them. So what you do is you minimize them so that you just don't want a bunch of extra flammable hydrogen sitting around your rocket in a cloud when they light the bottom and it goes up, because suddenly you get this explosion around, and you want the explosions to be happening inside the engine where it can push the spacecraft. So they got over the limit, and so they stopped their test. So on February 3rd, we were like, uh-oh, this is a problem. Let's see what happens. Maybe they'll still make the date. Well, they didn't. And they said, well, we're not going to make the February launch options, so we're pushing to March. And then they did some repairs and some tests and things like that. And that worked out fine. And they said, okay, we'll do another rehearsal. We'll do that whole full thing again. And if that works, then we can launch in March. So they got all geared up for that. They did another test first. They decided to, review the data. That's a great thing that NASA does. They're always reviewing the data rather than telling you what they're going to do. And that way they're hedging their bets in terms of, they're making a decision, it seems sometimes. But so that got us to the 13th. Then by the 16th, they set the date for the rehearsal, another 50-hour countdown. The whole thing actually went really well. It was perfectly in step. They were even ahead on a few things. They fueled up the whole thing. No hydrogen leaks. I mean, no hydrogen leaks that were worse than they were supposed to be. So there was still a little bit, but everything worked great. They counted down all the way to T-minus 33 seconds, which is where after that point, the computer basically takes it over and it goes automatically. So that's where they sort of practiced to. Then they brought it back to T-minus 10 minutes and held it there for a few minutes. And the idea is like, if you run into a last minute problem, but it's only going to take a couple minutes to fix, you can pause the countdown and then fix it and then just keep going. Something like, if it's there's lightning, but it looks like the storm is abating, so you might go ahead. Or this has happened a few times. Someone in a boat or in a plane or something like that flies a little too close to the launch area because they want to get good pictures and they don't realize they're in a restricted area and somebody has to go chase them out of the way. That's happened a few times where they just have to hold the launch for like a couple of minutes. So they demonstrated that. And then they counted down again to T-minus 29 seconds. Everything worked perfectly. I went to bed thinking, March the 6th. Jeremy Hansen's going to the moon on March the 6th. And I didn't check my email first thing the next morning. And by the time I did check my email, we went from a perfectly successful fueling test to something else went wrong in a completely different part of the rocket. And not only did it go wrong, it was something they couldn't fix at the launch pad. And so they were going to have to take the whole rocket all the way back to the garage, the vehicle assembly building, to fix it. It's in the top part here. It's in the upper stage of the rocket, the interim cryogenic propulsion system, the ICPS, the upper stage, which is basically the thing that they'll use to boost into the bigger orbits. And it was leaking helium. And helium is not a fuel. It's something they use to sort of purge the fuel after the test, and it didn't work. And they don't know if it's the ground equipment or the filter might be plugged, or basically it sounds like, if you got a noise in your car and you take it to the garage and they're like, what's wrong with it? Well, there's this thing, but I don't know what it is. And then everything seems fine. Well, that's kind of what's happening with this thing. It's probably more complicated than my car is, so I guess I don't feel too bad. But unfortunately, it means they're hauling it all the way back to the rocket, to the garage. And so this was on the 21st. They could theoretically, it's a 12-hour trip back to the garage. If they solve it and fix it fast, they could get back to the launch pad and still make the March 6th date if the weather is perfect, and if they don't have any other problems, and if they can fix it in time. They looked at all that and they decided, that's unlikely. I mean, maybe we could, but we might not have the whole launch window of March 6th to 10th. It's a short one anyway. Let's just push to the next one. The next one starts April the 1st. So, April the 1st at 5:24 p.m. Central Standard Time is the current launch date for the Artemis 2 mission with Jeremy Hansen aboard. And that gives them like 6 weeks to figure out this problem, which actually does sound like a fairly simple problem. It's just a matter of what piece caused it and, swapping that out, and then get back to the launch pad. The poor astronauts, they keep going into quarantine so that they don't get sick when they're in space. And so like for 2 weeks before their mission, they go into quarantine so they can't see anybody else. And then the mission gets delayed. And so they come out of quarantine and they can go and, see everybody again. And then they have to go back into quarantine. They actually put them into quarantine after the second wet dress rehearsal. And they brought them out of quarantine the very next day when they realized they weren't going to go. So they're kind of getting probably a little bit antsy in terms of what's going on in their launch date. But again, I'd rather that they're cautious when you're putting people on board. It's one thing if you're launching satellites and you might lose money if something goes wrong and the rocket doesn't make it or whatever. But when you got people on board, it's better just get everything figured out in advance. So we're looking forward to that. So the astronauts are no longer in isolation. As soon as the mission was pushed, they'll go back into isolation, I think March 15th or so. And that'll actually be one of the signs for us that they might be on track, because they got to get the rocket out there, by a certain date, but then they can leave it out there for quite a while. And so putting the crew back into isolation will be the signal that, they really are ready to go in a couple of weeks. And James asks, does it need a third wet dress rehearsal? That's a real good question. The wet dress rehearsal was to prove that everything was working. I suspect that they would do a limited, like they'll tank it up as a test to make sure that the hydrogen leak is still fixed and is not a problem. I'm sure they'll do something like that. I don't think they have to do a whole 50-hour countdown test, because a lot of that is not just to test the spacecraft. It's kind of practice for the humans that are doing the work. And you don't want to run too many practices. They've run so many simulations where they can, simulate a problem and then learn how to fix that problem and things like that. Just running a run-of-the-mill, everything working dress rehearsal actually doesn't help the training too much. So we'll have to see. Jacqueline, it's a almost 10-day mission. So they launch, they spend about 1 day in Earth orbit, looping around one low orbit, and then they fire the ICPS, the upper stage, to go into a high orbit that goes out 100,000 kilometers or so. And in that checkout, they'll make sure the spacecraft works. They'll make sure the engines work. They're going to do some practice piloting. Of course, they'll make sure the life support and all that stuff, everything is ready to go. And if it is, then they'll fire the engine to go into their trajectory to the moon. And it's about 4 days to get to the moon. They're not stopping there. They're not landing. They're not going into orbit. It's just going to loop around the moon and come back. So they'll have about a 4-hour flyby where they'll get a close view of the moon. And actually, it's not as close as a lot of people think. It's not, it's kind of they're going to get the same view as you get through a telescope here on the Earth. They're not coming really, really close to the moon like the Apollo 8 astronauts did when they did their lunar flyby. They were really close to the moon. Because if you go into orbit around the moon in a new spacecraft that has not really had a lot of testing yet, and then the engine doesn't work, you can't come home. You're stuck there literally forever. And so they don't want to do that. So instead of orbiting the moon, it's just going to loop around under the gravity and then head straight back to Earth. It's called a free return trajectory. So an hour in Earth, or a day in Earth orbit, 4 days to get to the moon, 4 hours doing the cool close-ups of the moon, 4 days to come back, and then the re-entry and landing, and they'll land in the ocean in the Pacific off the coast near San Diego, and parachute down, and that will be that. So when it happens, we're going to be covering basically everything, and I will stay awake for 10 days, pretty much. And it's going to be a really cool event. Not just because, people are going to the moon, and it's also, there's a lot of things in the world that are maybe not something you want to watch and get excited about, but this is something that, I think there's a lot of inspiration value. I think of the kids that are going to watch this and grow up to be scientists or engineers or just scientifically literate. They're going to see, wow, science, let us go to the moon. More people believe in science. I like that idea. So anyway, it's going to be a really fun event. All right, there's a little bit more cool space stuff that's been happening that isn't related to Artemis, believe it or not. While they were doing all of the Artemis, while they were in the wet dress rehearsal countdown test, the NASA administrator, Jared Isaacman, basically came out on a report on the Starliner, the Boeing Starliner spacecraft. You might remember this. It's the competitor to SpaceX's Dragon spacecraft, and the idea is you don't want to just have one company building all your rockets, because then what if that company turns out to be run by a crazy person? You want to have something else. So the Starliner is there. It's had all sorts of problems. Boeing has had all sorts of problems, if you think of the news of the last few years. And this report came out that basically said, when you launched it, it had 2 astronauts on board. A whole bunch of things failed. They made it to the space station, and instead of staying on the space station for 9 days, they stayed there for 260 days or something like that, until they were able to be brought back on a different spaceship because it wasn't safe to come back on this one. And this is not the first test flight of the Starliner. They had 2 robotic flights. They only were supposed to do one, but that didn't work, and they had to do another one. And then their first human flight did not work at all. So it's had some problems. Well, this report wasn't really talking about that so much. It actually was saying that, this was a big deal, and people didn't make it a big deal. They were like, oh, it's no problem. The spacecraft was at a point where if one more thing had failed, they would not have made it to the space station. They would have been stuck in a spacecraft in Earth orbit without the ability to turn around so that they could re-enter the Earth's atmosphere safely. And they basically would have just eventually re-entered. It was that close. And we didn't know that at the time. There were some indications that, things were worse than they were letting on. But this seems to be the idea that folks in NASA were like, we have to make sure that Boeing doesn't, fail. Well, if the spacecraft is failing, they should have declared it at the time. Anyway, there's a bunch of things that will fall out from that. It was really weird, though, that they chose the middle of their countdown for the Artemis spacecraft, the countdown test, to come out with this report, because a lot of people were watching. So I'm pretty sure they did that on purpose, to make sure that the media caught what was going on. So we'll have to see what the fallout is from that. Boeing is probably not super keen on this program anymore. I mean, they're already at the point where if they don't get it flying soon, the space station will be retired before they get all of their flights in. So it's a bit of a mess. We'll have to stay tuned and see what's going on in the next little bit. And we also had, actually the day of the last show, I think, we had the first ever medical emergency on the space station, where the four astronauts that got there on the Dragon spacecraft, one of them had some kind of medical emergency that wasn't, a medical condition that they needed to come back to the Earth, not instantly, but pretty soon, so that they could have tests in a real hospital. They've got medical stuff on the space station, but not enough to diagnose everything. We still don't know who it was, although there's some ideas just based on some of the things. And so those four came back, and there were only 3 astronauts on the space station left there with their 1 Soyuz spacecraft, 1 American and 2 Russians. Well, finally, another Dragon went up with a full crew, and there are now 7 people back on the space station, which means it's not just maintenance. They can actually get back to doing all the science and all the cool experiments and the spacewalks and all the stuff that the space station is there for. And you can see clearly they're having quite a bit of fun with all the cartwheels and stuff like that. Those 3 guys in the back, they've been up there the whole time, and you can all obviously tell the newcomers to zero gravity there are having a great time. But it's great that they're back at full contingency. The Chinese space station Tiangong has its crew of 3 as well, and there's been some neat stuff about the other things they're going to put onto there. They're building a space telescope that will float in the same orbit as the Chinese space station. And when they need to fix it or change instruments, since there's no space shuttle around, it'll just go and dock with the space station, and they can work on it at the space station with their robot arm and spacewalks and things like that, and then send it back out. It's actually a kind of an elegant way to deal with a system like that. So 2 space stations back to full capacity, which is great. This brings us to the end of our show today. Thank you for sticking with me through the various hassles there. Hopefully, I will get the studio back into shape permanently with a functioning computer. So, please send us your images of the eclipse. We know that that's going to happen in March. There won't be a launch until April, so we will have at least one more show before the launch of Jeremy Hansen. But I'd love to see and hear about your eclipse stories. Please share it with us at space@manitobamuseum.ca, or you can visit us through the various social media for the Manitoba Museum, either through YouTube or Facebook. We're not on Twitter, but we are on Blue Sky as well now, so you can join us there. Thanks everybody for coming out to the show. Nice to see you all. I'm hoping for clear skies on Tuesday morning as well. Always a great time to spend some observing time, seeing something great like this. Nice to see so many people checking into the chat. Sorry with all the issues. I didn't have a chance to say hi to everybody, but really, really nice to see you all. And hopefully, as the weather warms, we'll have to pick a date to get out and do some telescoping again, because that's always fun to get the Dome at Home family together and spend some time under the sky. Good night, everybody. Have a great night, and we will see you for the next show, the last Thursday in March. Good night.